So in this video, I will be talking about Lab 2 Experiment 2, in which um, we wanted to simulate a switch of a room, so a light switch of a room. So basically, when we would turn the switch or flip the switch up, it would turn on the light, or in this case, when we press the switch, it will turn on the LED, and then we will press the switch and release, and it will turn it off. So again, we have a function here that's in our while loop that's called room lighting control, and then that's going to be the essentially the function inside the while loop that is going to reiterate every time, right? So now if we go into our function, so this function could have, or yeah, this simulation could essentially have been created in two different ways. So the first way is that I will talk about because it's commented out here, but it's pretty short, so I could go through that first. Um, it's uh, it's the static with the falling edge, basically. So to implement this using falling edge, um, what you had to do was essentially create a static bool variable, right, for the pre-switch, because we don't want that to be erased every time it runs. So that's going to be our we're going to set that as our pre-switch, as our static bool for pre-switch number 2, and then our our boolean switch, right, which is what we want to label our variable. And then so basically this on this part of the code here is saying that um, essentially to read the state at which the switch is. So read basically like if the switch is being pressed or not, and then set that equal to cursor switch, or set current switch to that state. And then here, right, if this is called falling edge here. So basically it's saying that if the pre-switch is 0, or if the pre-switch is not being like it's not pressed, right? So if the switch is not being pressed and then it becomes pressed, then to turn on the LED. So turn on the LED. So again, basically this is called falling edge, in which it's telling the it's basically saying if the switch was if the pre-state of the switch was not pressed and now it is pressed, then turn on the LED, and then set the pre-switch. Now then set the previous state of the switch to the current state of the switch. So that's one way you could have implemented it. The other way you could have implemented it using states. So basically, um, here um, we basically established some states at which the switch was would act, right? So okay, so let's go through that code. So using those definitions, or not definitions, but like these type of states that are here, that are said here. Um, so we have, sorry about this. Give me a second. So basically, right, we have a switch. We have a switch case. We have a switch in case type of format. So basically, we have the first case, right? So if switch weight 0, right? So basically, Um, this essentially in this case here is the LED is off, right? So the LED is off, right? So we're gonna, in this case, the LED is gonna be off, and then if the button is pressed, then it's gonna go on to case 2. So, or in the second case, which is the um, when the light is on. So then in this case, right, now we're gonna set the LED to be on, and then we're gonna have another if statement that says if the switch is released, then it's going to go on to the wait statement, right? So the next case is wait 1, right? Which is what we had said this here. So if the switch is released, then it's going to go onto this one here. So then once it's in this switch or on this like state, basically what's going to happen now is it's going to continue to stay on. The LED is going to stay on, and then if the button is if the button is like pressed again, then it's going to go on to this one. It's going to go on to the next. It's going to go on to the next case or the next state in which the LED is going to essentially turn off, and then if the switch is released, then it's going to go back onto the case statement here, and it's going to continue rotating or going over and over. So basically, it's just the different states at which the switch is being pressed. So this is a longer way to implement it, but you could see like I guess like a little breakdown which states like so when this is pressed, the LED is off, but when it's pressed, you go on to the next state, and then like that. So yeah, so now I'll be showing the results for this code here, and yeah, I'll again mention some things from the code, but essentially this is what the code looks like. So again, there was two ways: one using falling edge, and the other way using the different type of states. Yeah, so the case statements, the case switch statements. So yeah, let's get to it.
In this video, I will talk about the results for experiment 2 in lab 2, where essentially I wanted to simulate a light switch of a house, which is also referred to as a single pole switch. So a single pole switch has two positions, an on and an off position. If we look at any switch in general, right, when we toggle the lever to the on position, it's the switch gate snaps closed, which allows the current to flow through and for there to be light. And when we toggle it back to the off position, it opens the gateway up and it interrupts the flow of current, which therefore doesn't allow for there to be light. So essentially, I wanted to simulate that here on this breadboard. So basically, what I did was I implemented that exact same, I guess, function into this microcontroller back here using a software edge detection, which essentially I use to determine the pre-state and the current state of this switch here. So the pre-state would basically be the state that the switch was at before and what it's at now. So essentially I use that to again code it onto my microcontroller back here, and then allow for this LED to turn on and off. So now for the results, if I were to click this switch button here, click turn it on, the LED is on. I click the switch back, the LED turns off. Essentially, this is what we also see in the light switch of a household. So again, I click the button to turn it on, and then I click the button again to turn it back off. And yeah, that's pretty much it. On and off. Yeah.